Seema Manu from Achievers International Public School, Sathanuru, Mandya. So now I'm here to explain you all about the telescope, and now I'm here to share my experience about the workshop that is Junior Scientist. Firstly, let us know what is telescope. It is just a device which is used to view the celestial bodies. It is also known as the celestial time machine. As we all know that universe is infinite. Isaac Newton, who is one of the famous scientists, he introduced the mirror-based telescopes. This telescopes uses concave mirror and as well as convex lenses. John Dobsonian, he is also one of the famous scientists. He introduced the simplest telescopes. Then Milky Way galaxies where we exist, it is the band of light. Sunspots. These are the spots on the sun, which is known as sunspots. There are some spots in other celestial bodies, such as in the moon. They are known as craters. Then glass blanks. These are the glasses which are cut in the circle shape. These are known as glass blanks. Do you know where the stars takes birth? Stars takes birth in cosmic cocoons. Vikram Sarabhai, who is a famous scientist, he is also known as the father of the space industry. And 4 inches telescope making processes. I'll say in the simple way, that is aperture 10 mm and the thickness is 19 mm glass which is inside this telescope. And focal length is about f8 to f12 and focal radio is as per the mirror grinded. Mount is the Dobsonian. This is known as the Dobsonian mount. This is odd to AZ and number of hours is 35 to 40 hours. Then dark patches on the moon, as I have already said, it is known as craters. And Jupiter is the largest planet, as we all know that, in the solar system. And it is made up of gases, which is known as the gas giants. The main process known as collimation, it is nothing but the process to know how to use the telescopes properly. This is known as collimation. Primary mirror mount, in the sense PMM. It is a mount in which we keep the 19 mm glass upon it. It is inside this telescope. And Galileo Galilei used and improved the telescope and he used it in the astronomical observations. Galileo Galilei found refracting telescopes and Isaac Newton found reflecting telescopes. Various strokes such as overhang strokes and W stroke, center to center stroke and zigzag strokes. Overhang stroke in the sense 10 mm glass as we keep it as a base. This is the 10 mm glass and 19 mm glass which is inside the telescope. We keep this 10 mm glass as a base and we take the 19 mm glass. Here we have to take this 19 mm glass 30 degree right side and we have to rub it upon the 10 mm glass. This is known as overhang stroke. And center to center stroke. We have to rub 19 mm glass upon 10 mm glass in the center. This is known as center to center stroke. And W stroke. We have to rub this 19 mm glass upon 10 mm glass in the W shape. This is known as W stroke. And zigzag stroke in the zigzag shape. And double W stroke in the sense we have to rub this 19 mm glass in the W shape twice. These are the strokes which we used in the telescope making. Then we have to do all these steps to make the glass clearer and as well as transparent. It is clear that we need to use the chemicals in the proper amount. Then finder scope. This is the finder scope which you can see, which focuses the object to be viewed. This finder scope views the images magnified and finder scope is required for the telescope to work properly. Glass blanks, as I have already said, it is cut in the round shape and these are flat. Let's start the telescope making process or telescope making procedures. There are various processes in telescope making. Firstly, let us know some processes such as grinding or polishing, etc. These are all important and necessary to do because we have to make the glasses transparent and as well as clear. Firstly, they will give the telescope kit. There will be various materials in this telescope kit. Those are 2 glasses, that is 19 mm glass and 10 mm glass. As I have already showed, this is the 10 mm glass. This 19 mm glass is thick and it is used as the mirror after all these processes done. And this 10 mm glass, it is very thin and it is used as the base. Next, they will be giving one tray. This is to wash the glasses after each chemical being used. Then one base plate because it is white in color and it helps to keep this 10 mm glass upon it. one pillar gauge. It is white in color, which is used to check the sajita between the glasses. Then what is sajita? It is the gap which will occur between the glasses when it is rubbed with each other. Then they will be giving 11 chemicals. Those are SiC in the sense silicon carbide 100, 120, 180 and 220, and Al2O3 in the sense aluminium carbide 600, 800, 1000 and 1200, and other two chemicals like cerium oxide and red oxide. We will be providing one spoon which is white in color, which is used to put the chemicals on the glasses. The various processes used are rough grinding, fine grinding, which are the types of the grinding, and polishing, mounting, then preparation of PMM and SMM in the sense primary mirror mount and secondary mirror mount, and preparation of this finder scope, collimation, alignment, and finally the test of star gazing. Firstly, let us discuss about the grinding. There are two types in grinding. Those are rough grinding and fine grinding. Rough grinding. Here, it is the first process in the glass making processes. We use some chemicals in this process such as SiC 100, 120 and 180. Grinding is the process when 19 mm glass and 10 mm glass are rubbed with each other to make the 19 mm glass concave shaped and clear and transparent. Here, when 19 mm glass become concave, at the same time 10 mm glass become convex, as it is used as the base to rub the 19 mm glass upon them. The chemicals used are SiC in the sense silicon carbide 100, 120 and 180. Firstly, we put silicon carbide 100 on the base glass, that is 10 mm glass, and start rubbing the 19 mm glass upon it. After we done, we need to take the pillar gauge, and here we can see the sajita in the sense the gap between the two glasses. We need to take the pillar gauge and we need to put 0.2 and 0.4 size between them. If it is moving, and we need to move to the next chemical, that is silicon 100 120. Next chemical is silicon 100 120. We need to put this chemical pint by pint on 10 mm glass, and we need to rub 19 mm glass upon the 10 mm glass. After this chemical done, we need to take the pillar gauge, and again we need to check the sajita. Next chemical is SiC 180. Here again we need to do the same procedure, that is we need to put pint by pint of chemicals on the 10 mm glass and rub 19 mm glass upon it. After this, we need to take pillar gauge and check the sajita between the two glasses. Here, by rough grinding is finished, and we need to move to the fine grinding. Before that, I said you, after all the chemicals being used, we need to check the sajita. Then how to check that? In the sense, we need to take the 19 mm glass and keep the metal scale upon the 19 mm glass. You can see the gap between the metal scale and the 19 mm glass. This is known as the sajita. We need to put the pillar gauge inside this 19 mm glass or sajita. Then it is important to remember that glasses, base plate, tray and spoon, etc. after using each chemical, it need to be washed, as each chemical can affect the other chemicals. Fine grinding. It is also one of the method of the grinding. Here we use various chemicals such as silicon carbide 220 and Al2O3 in the sense aluminium carbide, that is 400, 600, 800, 1000 and 1200. SiC 220. Here we use overhang strokes in the sense we need to take the 19 mm glass 30 degree to the right and we need to rub it. And Al2O3 400. Here we use overhang stroke. Al2O3 600 and 800. We use the center to center strokes. And aluminium chloride 1000 and 1200. Here we use W stroke or zigzag stroke. Hereby the fine grinding will also be finished. And polishing, it is the main process. Polishing is the process where we rub the glasses with each other to make the glass clear and transparent. Here we use two chemicals such as cerium oxide and red oxide. Cerium oxide, it is white in color. It is very fine particles. Then pint of chemicals is put over the glass and we need to start rubbing. Before that, there is a material called pitch lamp. Here you can see that this is the pitch lamp. So it is made up of the beeswax and as well as the rosin, which is in the honeycomb shape. Here you can observe that it is in the honeycomb shape. and it is attached to the 10 mm glass. This beeswax is attached or pitch lap is attached to the 10 mm glass, and we use it as a base, whereas 19 mm glass is rubbed upon this. Then this is given to make the 19 mm glass clear, smooth and as well as transparent. Here, instead of putting water with chemicals, we put soapy water to make it slippery as it is easy for us. Here, we will do center to center stroke and as well as W stroke. Then, how to check whether the glass is transparent or not? Yes, I'll say you that. Once the glass is being rubbed, we have to place the glass on the written paper, and we need to check that it should be clearly seen when we kept on the written paper. By this we can check whether the glass is being transparent or not. Then next chemical is red oxide. It is red in color like blood, and it has very small and fine particles. This red oxide is mixed with the soapy water, and we will start rubbing. After this, 19 mm glass is seen in the light. We have to keep the 19 mm glass in the light, and we need to check whether the scratch marks or the pits will be gone or not. Then we need to wash everything and pack 19 mm glass and send it to one of the company to make the mirror lining, which is known as aluminization. Next, they have given 10 mm glass for us for our memory. Then the next process is mounting. This is the mounting. The next step we have to do is mounting. They will give wooden pieces, and we need to join wooden pieces with the help of the screws, nuts and as well as bolts. Next, they will be given two circles. These are the two circles which is used as a base, and these are the two small circles, and they will be given a long rectangular bars with U-shaped structure on the top. These are the rectangular bars with U-shaped structure, and they will be given a small rectangular box, that is, this is that piece, and we need to arrange these pieces of wood carefully in the way that telescope should be placed. The stand to place the telescope is called as the Dobsonian mount, which was found by Dobsonian, who is one of the scientists, and PMM and SMM. Next, we need to make the primary mirror mount, which is PMM, and secondary mirror mount, which is SMM, to hold the primary and the secondary mirror to reflect the light in the telescope. Finderscope. This is the finderscope. The next main step is to prepare the finderscope. Finderscope is the small telescope on the telescope to find the direction and to make the object viewed to be magnified. Then collimation. It is the main step is the collimation. Collimation is nothing but the process how to align the finderscope, PMM and SMM, and even the process to know how to use the telescope properly. This is known as the collimation. It is one of the most important process. There are many rules for collimation, mainly 6 rules. Those are: rule number 1, PM should be arranged properly, because if not, 90% of collimation error occurs. Then rule number 2, we should always have the tools, mainly screwdrivers. And rule number 3 is that we need to give at least minimum 15 to 20 minutes of time for collimation process. And rule number 4 is no screws should be tightened or loosened. It should be fixed correctly. Next, rule number 5. Telescope tube. This is the telescope tube. It should be placed horizontally while doing the collimation process. And rule number: no parts of the telescope should be damaged by the sweats or any water. Rule number 6 is that never put eyepiece while collimation process. This is the eyepiece. We should always take out this eyepiece while doing the collimation process. Now, before alignment, we need to check the focal length. Then how to check the focal length? Here there is a formula. Let us know that, let us assume that focal length is 91. And then primary mirror mount is equals to focal length plus 3. In the sense, 91 plus 3 equals 94. And TTL, in the sense, total tube length, is equals to primary mirror mount plus 10. Then 94 plus 10 is equals 104. Then 104 is the focal length of this telescope. After finding this, we need to do the alignment. In this alignment, we will be given focuser, finderscope and its mount and long tube. And we need to arrange this properly After this, we need to align it carefully in a proper way that the telescope should be kept in a proper way to look the celestial bodies. The last is to view the stars, moon and other celestial bodies. Even I seen the moon, stars and planets such as Mars, Jupiter and Saturn. I felt very happy by seeing these objects, celestial objects. Thank you all for giving me this opportunity. Have a scientific day.